What? Did you have class at 9 o'clock?
Yes.
What class? Which teacher? Who? Isabel. I thought you said algebra. Okay. So write that down. Principle of moments. Got it? Yep. Alright, so have a look at this.
What number lecture is this?
I think it's 13. Okay. So you got a piece of wood. What would happen if equal but opposite forces are applied at the end? So, are you ready? What's, oh, no. Are you going? No. Do not get up in the middle of class to charge your phone. Sit down.
Is that like a break?
No, you don't need your phone charged because you can't use it.
I need to go to the bank later.
At what time?
Like at 3.
So why do you need your phone? Why are you so panicked? What's wrong?
I'm scared what if it dies, I don't know how to get back.
Alright, fine, just...
Thank you.
Goodness. Alright, so here is your plank of wood. So what happens if there's a force here and a force here which is the same? Will it move up? No, because this will cancel this. What? Did somebody say yes?
Yeah.
No. It won't move up, right? Will it move this way? No, because there is no force this way. So there's the force up and down cancel. Here and here is 0, 0, F and F. So in total in this picture here, the force is 0. But it will still move. But it won't move up, it won't move down. It won't move left, it won't move right. What will it do?
Just stand upright.
Yeah. It will rotate. Okay? So, if you want something not to move, it's not enough just to say that the forces cancel. There also must be no turning force. This one here makes it want to turn to the left. This one here makes it want to turn to the right. So together they'll turn. Yeah? Just a little bit of vocabulary. So look, that's a clock. Turning this way we call clockwise, and turning this way anti-clockwise if you live in Europe, and counter-clockwise if you live in America. What did you learn? Anti-clockwise is what you learned. Yeah? What did you learn? You know both. What would you use?
Anti-clockwise is good.
Yeah, I think I'll stick to using anti-clockwise, okay? But I think you know these words. Yeah. Well, it's the same in Chinese. Clockwise means with the clock, and anti-clockwise means backwards with the clock. Yeah? And I'm sure it's the same in Korean, yes? Yeah. Okay, back to the slides. Yep. Good. It would seem like it should not move, but it does. So what's the story? Well, the plank is moving, it's rotating. So a turning force is making it turn. If it is not turning, then it would be in equilibrium. So the key word I want you to learn here, equilibrium, means not moving and not turning. Everything is balanced. So please make note of this word, equilibrium. Please write it down. So an object is in equilibrium if the total net force is zero. Therefore, force to the left equals force to the right. Force up equals force down. And clockwise turning force equals anti-clockwise turning force.
What's the L again?
Turning force.
Okay. But it's not an L, right? Is it an L?
Oh, there's so many letters you could use. You could use J, L, tau.
Okay. So for now it's just L.
Yeah.
We call it torque.
And torque, and there's so many names for it. Turning force, moment, torque. Sure. I'm trying to stick to the word which they might use in the exam, which is moment or turning force. Or torque. Sorry, actually, they could use all three. Let me write these down. Yeah. L is turning force, which is force multiplied distance. There are other letters you can use. Some books don't use L. Some books use tau. Some books use gamma. Sometimes it's not called turning force. Sometimes it's called moment. Or sometimes it's called, as you said, torque. So you have at least 3 different words you can use and 3 different letters, but they're all the same. It also depends on what type of physics you're doing. So in mechanics, we usually use turning force or moment. But in engineering, like with cars, they often use torque. Okay, back to the slides.
So this is a moment of force we say.
You could also say moment of force too, yeah. But in fact, moment by itself is okay. Yeah. Alright, continue. Yeah. Okay. The last point is known as the principle of moments. That's not important. Basically what's important is if it's in equilibrium, they all must be equal. That is very important. Very important. Okay. Thank you, Sophie. Yes, those 3 equations are what's important. Okay. So please write this down as our first example. Put one of the lights on.
Is it supposed to be a 40 kilogram boy sits at the end or and the end?
I think when it comes to vowels, the A and the AN, it's if the next word starts with a vowel sound, not a vowel A-E-I-O-U. So a 40 kilogram boy sits at the end of a 100 kilogram sits at the end of a one.
No, it says sit and the end.
Huh? Oh!
Yeah.
A 40 kilogram boy sits at the end. Yes, let's just say at. Yeah. Not and. That doesn't make any sense. a capital F. It actually has a different meaning if it's a capital F.
What does it mean?
Funny enough, it means God when it has a capital F. Yeah. Which seems like a big difference for one letter. Although, I suppose it still makes sense if you kept it like that. Trade questions. Is that okay with you? Okay. They are easy questions to do. Of course, my homework is always easy. It is. Okay, we'll do this one? Okay. So, what's happening here is that the boy is here and the sister is here, but the boy is heavier than the sister, so it should move. So what the father decides to do, he changes where the pivot is so that it will be balanced. So the sister is here still, and the brother is here, but now it's balanced. The father, he moved the pivot so it's balanced. So the question is, where does he put it? So let me put in some distances. What is the total distance? 5 meters. So if I call this distance here from the pivot to the boy x, then how much is this distance? 5 minus x. How many forces are there? How many forces are there on the seesaw? 3, 2, 1. So what do we think, really? How many forces should I draw here? On the seesaw? On this seesaw, how many forces?
2, right? No, 3, 4, 5.
The answer is 4. So the first force is the girl. What's her mass?
She 30 kg.
So this is 30 g. The second force is the boy. What's his one? 40 g. The third force is here. No, this is the weight. 40 g.
No, it's 40 kg.
Yeah, he's 40 kilograms, so the weight is 40 g, 9.81 g. Yeah, no, he's not 40 grams. This would be a serious problem if he was. Now, there's a weight. How big is the weight? I think I said it was... Oh, sorry, not the weight, the seesaw.
100 kg.
I said it's 100, so here is a 100 g. And what is this distance? It is 2.5. And this distance is also 2.5. And there's still one more force. What did I not draw? One more force? Well, look at the picture. How many forces have I drawn? 3.
1, 2.
Yeah? So which way should the seesaw move? It will start to go like this. So there's one force missing. A very important force.
But then
No,
it's
no,
G.
no. No. Why does this seesaw not fall down to the ground? Because there's a reaction force going up to stop it moving down. So there's an ore going up right here. Because if there wasn't, it would go like this. It'll just go straight down. Which of course it doesn't. Yes? Right. So, this is in equilibrium. It means it's not moving. So the force that's going up should equal the forces that are going down. So I get R equals 30G plus 100G plus 40G. So R is 170G. So R is 1667.7 newtons. But also, it's not rotating. So, look up at me. What is this one called if it's going this way?
Clockwise.
It is clockwise, and this one? Anti-clockwise. So if it's not rotating, it means the clockwise equals the anti-clockwise. So the clockwise equals the anti-clockwise. Okay? Continue? Right. Let's take this as the turning point, the pivot, here. So this force from the girl is a clockwise or anti-clockwise force? This way.
Anti-clockwise.
And this one? Anti-clockwise. And then the boy? Clockwise.
No, wait.
Yeah.
That's right, yeah.
Oh, sorry, I drew it the wrong way, but yeah, it's still a clockwise. Yeah. Okay, let's calculate for the girl. So this one here, what is the force? It is 30G. And what is the distance to here? What's the distance from here to here? Now that's a little bit difficult to see, maybe. No, it's not actually. It's just 5 minus x.
5 minus x
From here to here.
plus x equals 5.
Well, slow down there. Plus 100 G. Yeah, no, it's 2. It's this distance from here to here. 2.5 minus x.
I'm trying to find the x.
Yeah. Well, here to here is 2.5, isn't it?
Yeah.
And here to here is x. So this piece here is 2.5 minus x. Is that okay, Grace? Look. 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 Here to here, how much? 2.5.
Yeah.
Here to here, we said at the start is x, didn't we? So then, how much from here to here? 2.5 minus x. Which is, sorry, no, now I know why you're confused, because I'm being stupid. I forgot to add on plus 2.5. Because I should do the no, wait. No, bad teacher. I was right the first time. It's the distance from here to the turning point. That was right. Okay, and then for the boy, what's his force? 40G. And what's the distance? The boy to the turning point? What's this distance? It's x. Okay, so let's calculate this here. So that would be 600g minus 30gx plus 250g minus 100gx equals 40gx. So what's nice is there's a g everywhere. I can cancel all the g's. Question? Did I make a mistake? Okay, I can live with that. Right, so I have here 600, let's see, how many x's do I have? Minus 30, minus 100, minus 40, x equals minus 600, minus 250, yeah. Hang on. That is six. No, sorry, that's not 600. That's 150. First one there. Just fix that, please. That should be 150. So that should be 150. Okay, x equals 2.06 meters. Question? Let's get one at a time. Yeah, let's get questions. Yep.
You say it's clockwise
Yep.
equal
Yes.
anti-clockwise, but they are anti-clockwise.
No, would you take this as the center of the clock?
Yeah.
So if you look here, this one here is making the clock turn anti.
Yeah.
This one here is making the clock turn anti. But this one here is making the clock turn clockwise.
Ah.
Well, I'm looking at this upside down, sorry.
Yeah.
This one here is
Yeah, anti-clockwise.
anti,
Clockwise.
this is clockwise for you, yeah.
Mm.
Yeah. So these two equal this one. And it's this distance, and then this distance. Yeah. So that's okay, yeah? You're okay with that? And you're okay with that? Okay. Now, if you have a question?
This equation, it is
Mm-hmm.
clockwise.
Yep.
Turning force will be equal to
Yes.
anti-clockwise. Reverse force, weight, 30g,
Yep.
and the distance.
From here to here.
Yeah, just
Yeah.
595. Plus, what's this is the force of that seesaw?
The way to the seesaw, yeah.
Okay, and then this is
The distance from the center of the seesaw to the turning point.
I see from this one.
Yeah, it's the distance from here to here.
Here to here.
Yeah.
Okay, this one.
Yeah.
So can I have a question?
Yes.
Because it's, I understand why it's like from the pivot point,
Mm-hmm.
the left equals the right.
Yeah.
Right. So, but why just say like it's 100g times 2.5 minus, because it's the 100g is the whole thing, not only that point. Right?
No, the 100g is the seesaw's weight, like if it's made of metal or something.
Yeah.
Yeah.
But it should be constant on both sides. Why just say on the
What do you
left
mean it should be
side?
counted on both sides?
Because like I understand, like you see the girls 30
Yeah, 30g, the seesaw's 100.
Yeah, the seesaw's 100,
Yeah.
but the girls on the left side, the seesaw is the whole thing.
On the left side? The
Yeah.
seesaw, the 100?
Yeah.
No, that's just a piece of metal. That would still be 100 if there was no one on it.
Okay, so as long as it's on the left side, that's it.
Oh yeah, as long as the center of gravity of the seesaw is to the left of the pivot, the seesaw will help to turn.
Okay.
Yeah.
Yeah, okay, I get it.
Yeah. Okay. Next example. Wait, for what? Then I will be waiting very long time. Continue? Amanda?
Yes.
Alright, great. Right. So you have a 100-gram meter stick and it's suspended by 2 strings. So you know what? I'll just draw it here for you. The first string is at 25 and the second is 90. What are the tensions? Okay. So let me draw it here. You have a meter stick. It is 1 meter long. And then here, at 25 centimeters from the beginning, whoops, I drew it upside down. There's a string. And then here at 90 centimeters, there's another string. So this distance is 25 centimeters, and this distance here is 90 centimeters. And I tell you it's 100 grams. So right in the middle here, there's a weight of 0.1 g. And that distance is 50 centimeters, of course. 50 centimeters. 50 centimeters, 90 centimeters, 25 centimeters. So what you've got is you've got a meter stick and there are 2 strings holding it up. That's what's happening here. Can you picture that? Yeah. So you got your meter stick with 2 strings holding it up. Okay, so I want to know how much force is in each string.
This is 0.1 kg.
Yep. The mass is 0.1 kg, so the weight is 0.1 g.
Yeah.
Continue. Right, so how many forces are here? How many forces?
1, 2, 4. Is it the same as earlier?
No, 3. There's the 2 strings pulling it up, we'll call them T and S. And then there's the weight going down.
And the resultant force? The resultant force is T and S, is it?
No, the reaction force, the strain tensions. Yeah. So we know that T plus S must equal W, which is 0.1 G, which in newtons is 0.981 newtons. Okay. Now, I'm going to take, in fact it doesn't matter where you put it, but I'm going to take the turning point as being here. No, you know what? I'm going to take the turning point as being here.
Why?
Grace! You're not listening to me today. What's wrong with you?
Nothing.
It's Monday, that's what's wrong, yeah? I'm going to put the turning point here. In fact, you could put the turning point anywhere, and believe it or not, you will still get the same answer. Where would you like to put the turning point? You can put it 1, 2, 3, 4, 5.
3.
You want to put it in the middle? All right, as you wish. So we'll put it in the middle.
Good turning point?
Yeah. Will this force make it turn clockwise or anti-clockwise? This one.
If it's pulling,
Yeah.
it will turn clockwise.
It will want to turn clockwise, and this one, it's trying to turn it anti-clockwise. So let's calculate now. That is T, and then what's this distance here? Yeah, 25 centimeters. And that should equal S times, and what's this distance here? You do? 40.
40. How did I 40?
Well, here to here is 90, and here to here is 50.
Yeah.
So you get 0.25 T minus 0.4 S. equals 0. Now, what type of problem is this? It is now a very simple math problem. This has t and s in it. This has t and s in it. So for example, if I want to cancel the t, what do I multiply this by? To cancel t? By 4. Because then this will be the same as here and you can cancel. Yeah? Huh? Why 4? What's 0.25 multiplied by 4? It's 1. So you have 1t and 1t and then you can cancel. Anyways, you did this in maths class last week, didn't you?
Long time ago.
No. You did it with Roland like 1 week ago.
A few weeks ago.
2 weeks ago then. Anyways, I'm not going to do that because I trust that you know how to do that. So when you solve these together, you will get t equals 0.604 newtons and s equals 0.377 newtons. I'm going to trust that you can solve this degree 2 system. Yes? Continue? Yes? Okay. 2 men are carrying a 50, I'll just draw it. 50 kilogram steel, it's 3 meters long. The first man is 10 centimeters. You know what, this question really is the same as the last one, except instead of strings, they're men carrying it. Yeah, I don't think I need to do that, it's okay. Well, just in case, wait. Let me just give you some vocabulary before you go with this question. Now, I'm being a little bit sneaky in this question, I'll just draw it for you. So what you have is, I think I will do it actually. Sorry, changed my mind. You have 2 men carrying this beam of steel. It is 3 meters long. It is 50 kilograms. And the center of gravity is not in the center. It's a distance of 2.1 meters. So how big is this distance here? 0.9 meters. The first man carries it at 10 centimeters and the other one carries it, where is the other one? Sorry, that's my question. So the first man is carrying it up here, and this is 0.1 meters. And the second man is carrying it here, and you don't know this distance, I'll call it x. And the question is, what is x? Yeah. And I don't tell you the force as well. So this here, we don't know. We want x. Yeah. Okay, so we can have t plus s. What should that equal? How much? 50g. That's the first one. Secondly, this one here, clockwise or anti-clockwise? If I take this as the center. Try again. Oh, sorry, clockwise. This one here, anti-clockwise. T times, what's the distance from here to here? No? Who can tell me here to here? Come on. 2. Because this is 2.1 and this is 0.1 equals s, and what's the distance from here to here?
6.1 to 0.8.
No, you don't know this. So it'll be, what is it? Point
0.9 minus
9 minus x. So you get 2t minus 0.9 minus x s equals 0. Now here's the problem. How many equations do I have? How many equations?
3.
No, I only have 2.
3 t plus x equals.
No, this is the same as this one.
Okay.
Yeah.
So it's 2, yeah.
So I have 2. How many things do I not know?
3.
3. What are they? T, S, and X. So do I have enough information? No. Is there any more information in the question? Tell me.
10 centimeters from the end of the.
No, I used that already.
The beam is in equilibrium.
I used that already.
The center of gravity is 2.1.
No, I used all of this.
So that the beam is
They're twins.
Yeah, I used that.
They're twins.
They're twins.
So it's the same height.
They're twins, so that T equals S.
What?
Yeah. So they're twins.
But one of the twins can be stronger than the other.
Yeah.
Fine. They are identical twins. Okay.
What if one of the twins goes to the gym?
Yeah. Okay. Fair enough. If one of the twins goes to the gym and the other doesn't. Yeah. Okay. So now you have enough information. Okay. So you can now put that in there to get the T and the S. So you'll get T equals 25G and S equals 25G. And then you can take these and put it in here to get the X. So you'll have 50G minus 0.9 minus X times 25G equals 0. So if you take that over and then you divide it, you get a 2. You get, sorry, you get this. That doesn't seem right. That seems too big. 25, 50 minus 0.9. I got a really big number for x. 2 equals 0.9 minus x. X equals 1.1? No, that's too big. Something... T plus S equals 50G. It is 2 here, from here to here. And that is 0.9 minus x, s with the minus. T equals s, that's 2, 25G. I got x as 1.1, but that's too big.
Okay.
So there's some small mistake here. Anybody see it?
Yes.
What?
The whole thing. The question is a mistake. No, maybe it's not actually 3 meters.
No, I did say it was 3 meters, didn't I?
Yeah, but maybe it's not supposed to be 3 meters.
This is 2.1. This is 0.1. So here to here is 2. 2t, that's right. And then here 0.9 minus x, s, that's right. 2t minus 0.9 s, t equals s. $25, 2t, 25, 50. Thank goodness. Hell, my answer's not right. I know it's not right because x I get is 1.1. But that should have been a really small number, not a really big number.
Yeah.
So there's a sign mistake somewhere, but I can't see where.
I'm trying.
Where the heck did it go wrong? There's a sign mistake somewhere. T plus S equals 50G. That's right. 2 meters times T equals 0.9 times S. T must be 25G, S must be 25G. That's 50G. Take that over, divide by 20. That's 2. 2 equals 1.1 equals X. No. X can't be. X must be less than 0.9. That means there's a stupid sign mistake somewhere. 0.9 minus X. Ah, where is it?
Maybe 3 times people. Not the same number. No, you get the wrong
Two.
answer.
Oh wait, hang on. Maybe I'm just doing it wrong in my head. 50G equals 0.9 minus X 25G. True? Yes. 2 equals 0.9 minus X. True?
Yeah.
X equals 0.9 minus 2. X equals minus. Alright, so the problem is with the question. My problem is that this man should be over here because of the minus. So the problem is with the numbers. So yes, the question is wrong. But, oh well. Yeah. Because I shouldn't have gotten minus answer. But I didn't see any mistakes that I made.
It's 1.1.
With a minus.
Right.
With a minus is quite bad.
Very positive.
That means the B man's here and the other man should be over here. Quite bad. I will check this question after class. I'm sure I just made the question badly.
Okay.
Yeah. Anyway, what I wanted you to see in the question is the word twin. How it was useful. Yeah. Alright, here's your homework.
Bye-bye.
Yes, indeed.
No homework.
There you go. Got it?
No.
Got it? Okay.